Hello, I'm Sierra Bose. Welcome to my channel, Learningbuildslife, and today we're going to talk about Olympiad standard mathematics on the topic of mensuration. I'm going to read the sum before we can begin. ABCD is a diameter of a circle of radii 6 centimeters, such that AB equal to BC equal to CD. Some circles are drawn on AB and BD as diameters, as shown in the figure. Find the area of the shaded region. Okay, first let's understand this diagram very well. Here we have a circle with diameter is 80, and here we have to find this shaded region. Now, here we can see, as per information, is that AB equal to BC equal to CD. That means the three divisions of the diameter given over here. And as per the question, we can see diameter is of radii 6 centimeters. That means now we need to find out its diameter so that we can get the length of each of these three divisions on the diameter. Let's see. Here radii is given 6 centimeters. So diameter is obviously 2 times of that. So it is 12 centimeters. Now we got the diameter of the circle, the big circle. Now according to that, we need to get the length of each of the three divisions of this diameter. Let's make an equation. AB plus BC plus CD equal to 12. Or, now, here BC and CD, as per information it's given here, AB equal to BC equal to CD. Therefore, we can replace BC and CD with AB. And we can write it like this: AB plus AB plus AB equal to 12. Or 3AB equal to 12, or AB equal to 12 by 3 equal to 4. So now we finally got the value of the divisions on this diameter, that is AB equal to BC equal to CD. Now it's equal to 4 centimeters. So with this value, now we can move on to finding out the main thing in our sum, that is the area of the shaded region. Now to do that, we need to get the areas of certain semicircles. Like over here, the main circle, semicircle, that is with the, the diameter with 80, that semicircle's area has to be found out first. Then we need to get the middle one, and then middle-sized semicircle's area that is not shaded. And finally, the small semicircle with the diameter as AB. Now we can move on to finding it out. Now the thing is that we need to do specific calculations over here to get to our final result. Like, we need to subtract the area of this medium-sized semicircle from the area of this bigger semicircle with the diameter is 80, and finally again add this area of the small semicircle. So to do that, I'm erasing the board and we can move on to explanation of this, finding the area of shaded region. Okay, now first I'm going to do one special thing over here, is that I'm going to consider different variables for each of the radii of the different semicircles which I talked about previously. So for the biggest one, that is with the diameter is 80, we are considering the radius to be capital R. Please remember, I'm taking the biggest one as capital R, then I'm taking the medium-sized one, that is with the diameter is BD, as R, small r. And then finally, I'm taking the one AB, means with AB as diameter, that one I'm taking as R1 radius. Now, according to these variables, we can make our expression to find the area, and that is, this area means area of the semicircle with the radius as capital R minus the area of the semicircle with the radius as small r plus the area of the semicircle with the radius as R1. Now we can make this. So what is the area of the semicircle? That is half the area of the circle, and the area of the circle is calculated by the formula pi r squared. So accordingly we can do it as semicircle is half of a circle, hence it is half pi r squared. So accordingly we do it, and we have half pi capital R squared minus half pi r small r squared. So this we're going to work with this separately, hence I put a bracket, plus half pi r1 squared. That is area of the smallest semicircle, which I mentioned about. And totally centimeters squared. Now we can move on to solving this. Now first we have to take we can take something common here, that is half pi. I'm taking half of pi as common. And then in the bracket, we're left with capital R squared minus small r squared. Plus half pi r1 squared. Now to go further with this, we need to do some mental calculations, which may be very easy. Like to get our capital R squared, that is already given in the question. That is the radius of the big circle, that is 6. So we can easily replace that value. Now about medium-sized semicircle's radius, that will be 4, because over here it is a part of BC and CD. Both BC plus CD are making up the diameter, and as I told previously, BC and CD are equal, and also they are equal to 4 centimeters. Therefore, this small r is 4. We calculated that too. And finally, we can move on to calculating R1. Since AB is 4, and this itself is the diameter of the smallest semicircle, therefore, the radius of the small semicircle is going to be 2 centimeters. And therefore, R1 is going to be 2. Now we can do our substitutions and move on. So now we can move on to our next step over here, 36 minus 16 plus, I'm sorry, it's not getting accommodated here, to 4. Cancel this out, we get 2 over here, and we need to calculate mentally. We get half pi into, this is 20, plus 2 pi centimeters squared. And now we cancel this, we get 10 pi plus 2 pi centimeters squared. And finally, this is 12 pi centimeters squared, which is our final answer. That is the area of the shaded region. That is 12 pi centimeters squared. Now, why did I leave it 12 pi? I left it at 12 pi because 12 pi is a bit difficult to calculate, because values of pi, like 22/7 or 3.14, are a bit difficult to deal with. Hence, it is okay if you leave the answer to 12 pi centimeters squared. So I'm now giving you a few moments to look at this expression and sharpen your concept. Hope you enjoyed solving this sum with me, and please like, share, and subscribe my channel. Thank you.